Hi, and welcome back to my series about solving Project Euler problems using x86 assembly. Today we're going to solve problem 2, which is about finding the sum of all of the terms of the Fibonacci sequence that are less than 4 million and that are also even. Alright, so let's jump into some C code and get started. Okay, so here I am in a C program. I've written just a couple things already. I already wrote int sum equals 0 to store the sum, and then int a and b are 1, which will store the terms of the Fibonacci sequence as we calculate them. So, while a is less than 4 million, as specified, if a mod 2 is equal to 0, that means that a is even, we're going to do sum plus equal a. Then, what we're going to do is we're going to do int c is equal to a. It's going to store it as a placeholder for now. Then, a equals b, and then b is equal to c plus b. So what this will do, for example, with 1 and 1, is c will be 1, then a will be 1 again, because b was 1, but then b will be equal to 1 plus 1 is 2. So then we'll have 1, 2. Then, if we do c equals a, we'll have c is 1, then a equals 2 from b, and then b is equal to 2 plus 1. 1 from a from before, and then 2 from b. So this will calculate the terms successively until we have all the ones that we need. Each time we will be checking if a is less than 4 million, and then if it's even. And by looping in this way, we will be able to find the sum. And then at the very end, we'll just do printf of the sum, and that will give us the result. And once again, I'm not going to run this because I don't want to give away the answer. You have to code it yourself. But that's how I would do it in C. So let's go over to some assembly and see how I would do it there. Okay, so here I am inside of an assembly program. I've copied over some of the stuff from the first video, mainly the section with the printf digit string, and then these few things, which are recognizing the text section of the program, and then our main function and our printf function, which we need. And then this bit right here is just what you need to print out the value in RSI at the end of the code. In general, that's what we'll do. We'll just move the value into RSI at the end in order to print it. And then at the very bottom is just that return 0 part. So whatever we want to code needs to go right here inside of our main function. So just like in the last video, we're basically going to copy what we did in C and just translate it into assembly. In this case, we're going to need 4 registers at least, instead of just 1 or 2 like we needed in the first problem, because we need 1 for sum, and then 1 for A, 1 for B, 1 for C, and then we might actually need a 5th register to do some division. But we can start with just 3, because that's what we need at the top. So we need 1 for sum, 1 for A, and 1 for B. So right here, I will move 0. We'll use RDI for the sum. Actually, if we use RSI for the sum, at the end we might not even have to move it to print it out. So we'll do that for now. Then we'll use RDI for A, and we can use RBX for B. I don't want to use RAX because we might need that for division in a second. Later we might use RCX for C. It's kind of convenient because then B stands for B. Yeah, okay, whatever. Let's move on. So we need to loop as long as A is less than 4 million. So just like we did before, we'll do main loop for a label. And then at the bottom of this loop, we'll say compare A, which is RDI, to 4 million. 1, 2, 3, 1, 2, 3. 4 million to A. If A is less than 4 million, we're going to jump back up to the main loop. So this will do the check and the jump. And before this, we just have to do our Fibonacci stuff, and that will take care of the rest. With a for loop, you have to increment, but with the while loop, the condition is all that you need, and then the inside of the loop will take care of the rest. So right here, we just need to put our Fibonacci code, and then we'll be done, because we've already taken care of the printf at the end. So let's look back at our C code. The first part is this check if A is an even number. So let's just copy this over and we'll translate it. Okay, so if a mod 2 is equal to 0, if you remember from the first video, to check with a mod operator, we have to do division and then look at the remainder. So I actually still have that first program up. So we'll go right over there. Here it is. And I'm just going to borrow this part and I'll explain it again. When you're doing Project Euler Problems, you'll probably find that a lot of code gets reused from problem to problem. So here we are. We're going to use, instead of RBX for division, we'll just use RDX. So we'll move 2 into RDX, and then we're checking if A is divisible, so that's RDI. So we'll move RDI into RX. We'll correct our signage. Then we'll divide by RDX. Then the remainder is now in RDX, which is fine because we don't need to store that value of 2. So we're going to compare. Is RDX 0? Was A even? So this is all we need. And now, if it was even, we want to add it to the sum. Otherwise, we want to move on. So right here, I'm going to put a label, wasn't, or I'll say not divisible. And right here, if the remainder was not 0, in other words, if it was odd, we're going to jump to not divisible. Jump not equal to divisible. Otherwise, right here, we get to add A to the sum. So we'll add RDI into RSI. Okay, so regardless of what happened, we're going to end up down here in the not divisible section. Right here, we want to do the Fibonacci sequence. So that means that we need, if we look at the C code, we need to make a new variable that is a copy of A. So we'll do that first. We can use RCX. So we're going to move A, which was RDI. So we'll move RDI into RCX. Next, we need to make A equal to B. So RDI needs to be equal to RBX. So we'll move RBX into RDI. And then finally, we need to do B equals C plus B. So what we're going to do is we're going to add the sum B plus C. We're going to put that into a register, and then we'll copy that register into B. Well, actually what we can do is we can just do add Q C to B. Sorry about that. So C is RCX, so we'll add RCX into RBX. So this is like writing int C equals A, and then B equals A, or sorry, A equals B. And then finally writing B plus equals C. So this is the Fibonacci code that we needed. And so then when this is done, we get to check if A was still less than 4 million. And if it is, we'll jump back up to the main loop. After all this is done, we'll fall through here and we'll print RSI using printf. And then we're done. And that's that. So you can code this up yourself if you want to and try running it on your machine. And once you have your result, I'll meet you back over at the Fibonacci page. All right, so here I am back at Project Euler. I'm not actually going to go on to the Fibonacci page because I don't want to spoil what my answer was. But if you run the code yourself, feel free to go there and check your answer. Our code did work, so I've got these two done. So in the third video, we'll go over how to find prime numbers in assembly. And in fact, we'll talk about how to have multiple functions instead of just the main function that we've had so far. So stay tuned if you want to see that. If you enjoyed this video, please leave a like or subscribe. I'm going to keep going through this series, at least through the first 10 problems. We'll see how it goes through there. And thank you very much, and I'll see you next time. Bye-bye.